Hey everybody, we have this difficult looking problem here that we want to tackle using some properties of exponents and other algebraic tools that we think may come in handy as we go. The problem says to solve the equation if x and y are both positive. Right now, I don't really know how it's relevant that x and y are both positive, but I'm sure we'll figure it out along the way. The equation says the group 2 times x to the 0th power y cubed times the group 4xy to the 5th power over x cubed y to the negative 2nd power equals x to the 4th power. So this problem was designed specifically to practice using properties of exponents, but also utilizing a little bit of algebra and logic in terms of implementing that into an equation to solve. So let's dive in. I always start by rewriting my equation. It's also nice to really get to understand the equation a little bit more as we rewrite it. Now, I'm going to dive into tackling this, just implementing my properties of exponents. This is not me teaching how to solve this equation. This is me walking through how I would solve this equation. Maybe you would have a different technique. Let me know. So I'd start with x to the 0th power. I don't like things to the 0th power. They simplify to equal 1. I also see I have a negative power. I don't like negative powers. I can use the reciprocal to remove that negative power. So rewriting that, this 2 times x to the 0th power turns into 2 times 1 times y to the 3rd power. All of that grouped together. Over here, I said I'm going to flip this second group so that I no longer have a negative power. So I'm going to have my denominator come to the numerator and my numerator come to the denominator. All this just to make the power positive. Now the power is positive. I haven't touched the right side of the equal sign, so I'm just going to keep writing it as is. If it hasn't changed, it stays the same. I'm going to keep simplifying. I see that I have 2 times 1 times y, which is of course just 2y cubed. Still in my group though, can't forget about that group. Times, I see inside of this group here, there's some things that can be simplified. For example, x to the 3rd power over x. I know that's just x squared inside of my group. I also see y over y to the 5th power, which I know is y to the negative 4th power. And I still have that 4 in the denominator. All of that is squared on the left side. I haven't touched the right side, and so it stays the same. This here, I can simplify that by writing it as 2 to the 3rd power times y to the 3rd power, which is of course just 8y to the 3rd power, times, we don't like negative powers, let's bring that to the denominator, so it'll say x squared over 4 times y to the 4th power, now that the power of the y is positive because we took the reciprocal of it, on to the 2nd power. We haven't touched that too. We haven't touched the x to the 4th on the right side either. Continuing, I'm going to now apply this 2nd power into that group there. This 8y to the 3rd power, I'm just going to let it be for right now. And I see that I get in my numerator x squared to the 2nd power is really just x to the 4th power. In my denominator, I have 4 to the 2nd power, which is 16. And I have y to the 4th to the 2nd power, which is y to the 8th, equals x to the 4th power. Now I'm ready to just multiply these two fractions here. So in my numerator, I get 8. I'm going to write it in alphabetical order. X to the 4th power, y to the 3rd power. In my denominator, I get 16. Y to the 8th power equals, and the whole thing equals x to the 4th power. This, of course, can still be simplified. Doing so gives me 8x to the 4th power over, I'm noticing, this and this can both still be simplified. 8 over 16 just gives me 1 over 2. And y to the 3rd power combines with that y to the 8th power and gives me y to the 5th power in the denominator positive. we have all of that equal to the 4th power. And for those of you who are wondering why I wrote the 5 in the denominator, was so that I can skip a step. Instead of writing the -5 up here in my numerator power, I just skipped that step and brought it right down to the denominator where it was going to be. Anyways, now I've got this almost as simple as I can possibly get. I need to start finally moving things over to see what I can solve for and how I can solve for it. I'm seeing that I'm solving an equation where a variable is in the denominator. We do not like that. Whenever there's a variable in the denominator, we have to consider like, can this variable be 0? Because when it is 0, we're dividing by 0, and that creates the divide by 0 error. We are not allowed to do that. And so it's nice that they gave us the condition that y is positive, because that tells us that I don't have to worry about dividing by 0, because 0 is not a positive number. And so what can I do? Maybe I'm going to divide or multiply both sides times 2y to the 5th power. That cancels. I say I get x to the 4th equals x to the 4th. Times 2y to the 5th power. Maybe I can also divide x to the 4th from both sides. I'm only allowed to do that because x is also positive, which means x to the 4th is also never equal to 0. If it were equal to 0, that would be totally illegal for me to divide like that. And so on the left side, I get 1, because anything divided by itself is just equal to 1. And on the right side, I get 2y to the 5th power, just a basic algebraic equation that I can now solve for my variable y, it appears to be. So I'm going to just start peeling back these layers to get y by itself. I'm first going to divide out this 2, that's multiplying. And I get 1/2 is equal to y to the 5th power. The very last step I have to take is the 5th root of that y to the 5th power to undo that 5th power. And if I do it to one side, I do it to the other. And so we have it, y is equal to the 5th root of 1/2. Nice. We just solved that for y.